Okay, once again, maayong hapon kanatong tanan. Good afternoon. This afternoon would be a very exciting topic, no? We had one speaker who just flew in from Manila before all flights were cancelled. So we are very lucky to have him. But not so lucky for him because he would be, I think, stranded here in Cebu. But anyway, our speaker this afternoon is the director of Philippine Institute of Volcanology and Seismology, or PHIVOLCS, a position he held since 2003. He previously served as science research specialist of the same agency. He is a member of the Board of Trustees of the Earthquakes and Megacities Incorporated and the Philippine Society of Youth Science Clubs. He has an undergraduate degree in geology from the University of the Philippines, Diliman, a master's degree in geological sciences or sciences from the University of Illinois, and a doctorate degree in earth sciences at the Scripps Institution of Oceanography, University of California, San Diego. His distinctions include the Excellence Award for Government Service given by the Philippine Federation of Professional Associations in 2010, the Presidential Lingkod Bayan Award given by the Civil Service Commission, and the Outstanding Professional of the Year in the field of geology by the Professional Regulation Commission, among others. He declared as someone who is fondly called as the fault finder, but not the usual faults that we know. A big round of applause to Dr. Renato Solidong Jr.
Thank you very much. Aside from being called a fault finder, I've been going around the whole country, and sometimes in my lecture, I blow my whistle so that the people can simulate the drop, cover, and hold ducking under the table during an earthquake event. Because of that 17 regions, in the final leg at the PICC, I was introduced as a fault finder, and in the tune of the times, an appropriate description, also the whistleblower of DOST. Anyway, what I'd like to do today is talk about disaster imagination. But before I do that, I'd like to focus on certain things that you might not have experienced yet. So let me show you something which happened in Japan. And essentially this would be an earthquake. And since you haven't experienced a very strong earthquake yet in Cebu, let me show you what happened in Kobe, Japan. This occurred early in the morning, and the fault ruptured. That's the fault that moved, and then the fault motion caused vibration of the land. It caused destruction of old structures, making it to collapse, and then it affected urban areas in Kobe. Glass burst, all buildings toppled, hospitals were affected. Old structures collapsed. People inside those buildings were affected. Railroad tracks were bent. Country trains in liquefaction-prone ports were affected. Elevated highways also affected. Elevated roads with the soft foundation doubled. And no electricity. So that's what happened in Kobe way back in 1995. So can that scene happen also in any parts of the Philippines? Can that scene happen here in Cebu? We don't know. So essentially what we wanted to now focus is really what do we do so that these extreme events will not happen in our lifetime? Or if this will not happen in our lifetime, or if this will happen in our lifetime, what do we do so that we can reduce the risk? So my presentation is entitled Disaster Imagination, Key to Building Resilience to Extreme Natural Events. And I'd like to use earthquakes as an example of a hazard and use earthquake hazards and risk assessment appropriately to present to you a framework of an earthquake risk reduction plan. What is the reality? As you know, the Philippines is ranked third in many countries exposed to natural events. We are blessed with typhoons, storm surges, floods, and even landslides. Why do I call this a blessing? Because we need water to drink. And many dams in Luzon are now well below critical level, and they need typhoons to bring the rains. We are also affected by earthquakes, tsunamis, and volcanic eruptions. In fact, at some point, you could have considered earthquakes also a blessing, because Bohol, Cebu, Negros are islands that were lifted up from the ocean floor because of fault movement associated with earthquakes. If not for this, you would not have this beautiful city of Cebu, and RAFI would not be around. Of course, you don't want an earthquake to happen because this would be a devastating event. But before we focus on earthquake, let me remind you that indeed, people tend to prepare more for hydrometeorological hazards, like what happened in Mindanao, Typhoon Pablo. Many people would not forget this because more than 1,000 people died because of this. And then Super Typhoon Yolanda came, that affected Eastern Visayas all the way through Western Visayas to some parts of Mimaropa. More than 6,000 people died because of tall waves due to storm surges, but millions of houses were destroyed because of strong winds. So extreme natural events like a super typhoon would bring in multiple hazards. But just like super typhoons, earthquakes also bring in multiple hazards. However, compared to typhoons, strong earthquake events do not occur regularly. To the left of the diagram is a map of the Philippines showing you the different areas where earthquakes occur. And these areas are essentially almost the whole country except mainland Palawan. Meaning all of the Philippine archipelago minus Palawan Island have been affected by earthquakes in the past and can be affected again in the future. Where is Cebu there? Cebu is somewhere there. Not so covered with earthquake epicenters yet. Because our history is so short, only 400-year record. But this diagram is actually from 1907 to 2012 only. Like 100 years of historical earthquake monitoring. For the past 400 years, 90 destructive earthquakes have occurred. So almost one strong earthquake every 10 years, but it should not be following every 10 years. And what we don't want to see would be buildings that would collapse, and that those buildings that collapses would be those that would kill people. We would also see destruction of vital facilities like roads during earthquake events. Recently, Cebu was affected by the magnitude 7.2 earthquake which originated in Bohol province. Bohol was affected by a ground shaking strength or intensity of 7 to 8 in the epicentral area, and Cebu City and Mactan was affected by a ground shaking intensity of 7. We call 7 a destructive shaking and intensity 8 a very destructive shaking. 222 people died, and more than 70,000 houses were damaged. Roads, bridges, seaports were also damaged. Tomorrow, July 16, will be the 24th anniversary of the July 16, 1990 magnitude 7.8 earthquake, which affected Luzon Island. This earthquake, which originated in Rizal, Nueva Ecija, affected a big part of Luzon, including central and northern Luzon, and caused the death of more than 1,200 people, missing of around more than 300, and close to 100,000 houses damaged. I think for most of you, if you were asked, what would you remember out of the 1990 earthquake, you would remember hotels that collapsed, including the Hyatt Terrace Hotel in Baguio. However, there were many other effects of the earthquake. For example, the Baguio Park Hotel collapsed. The Baguio City Public Market collapsed like a pancake. But in the steep slopes, there were many landslides. And in soft grounds like in Pangasinan, in Dagupan, roads were fissured and buildings tilted because of liquefaction. In essence, because the roads were blocked by the landslides and communication was cut off, we really didn't know what happened immediately after the earthquake. Out of the 1990 Luzon earthquake, we learned many lessons. And the first is the public need to respond properly during earthquakes. Simply put, if you were asked, do you know what to do if there is a big earthquake here in Cebu? Your answer should be yes. If your answer is no, better review how to respond to an earthquake right after this lecture. Second lesson is that water, power, transport, communication lines were affected. Essentially, these are the lifelines. We need water, we need food also, but we need roads, we need bridges that would be used to convey these different motor vehicles. We need electricity, and we need communication. But there was interruption in communication, so there was difficulty in finding out which localities, which villages need help as soon as possible. Because of this, we recognize the need to simulate the hazards and the impacts or effects so that appropriate preparedness and response can be formulated. Meaning, even if we don't have any communication, we can scientifically estimate which cities have been badly affected so that we can send the responders right away. Fourth, we need to implement our building codes better. We also need to implement the land use better. Meaning, don't let houses built on steep slopes to be built on steep slopes where landslides can happen. Do you know that there were more buildings that were left standing than buildings that collapsed during the 1990 earthquake? Although in our minds, we remember only the buildings that collapsed, the reality is there were more buildings that were left standing than buildings that collapsed. In the Bohol earthquake, there were more buildings that were left standing than buildings that collapsed. But in our mind, if we recall the Bohol earthquake, houses collapsed. Why do I say this repeatedly? It is because those are proof, the buildings and houses that were left standing would be proof that we can build better houses, we can build better buildings that are resilient to strong earthquake events. Earthquakes should not be something like a problem which we cannot solve. We have the solution. The only thing is we should recognize that there is a problem and then we need to implement the solution. The fifth lesson is that we need many trained search and rescue groups and medical responders. I recall that it was like Mayor Gordon of Olongapo City that helped Central Luzon immediately, but we need to train more and more responders. So for example, Cebu City have an urban search and rescue group. How many? It's not only for Cebu City's need, but also these groups can also respond to many other disasters in other parts of the Philippines. So all of these were lessons that have been borne in mind, and I will show you how, for example, we answered the need to simulate hazards and effects, essentially developing a frame of mind which is really imagining the disasters even before it would happen. The question that I would like to pose using earthquake as an example on how to assess the risk is, can large earthquakes affect Cebu and vicinity? Or Cebu City and vicinity? What will be your answer?
Yes.
Yes. How big is your yes?
Big yes.
Big yes? Okay, let's see if your yes is really big or small. This is the earthquake or seismicity map of Cebu City, showing the earthquakes from 1907 to 2014. The areas encircled by a black circle there would be Region 7. And you would see that in Negros Island, there is a clump of earthquakes there, which is related to the 2012 magnitude 6.9 earthquake. Further in Bohol, right there, that is the magnitude 7.2 earthquake last October, and the aftershocks related to it. In Cebu, you recognize that there are small events, earthquake events already happening. Meaning, if there are earthquakes, then there must be earthquake generators or faults or active faults in Cebu. Okay? Historically, in Region 7, there have been significant earthquakes of magnitude 6 or greater. Okay? But here in Cebu, the only significant earthquake recorded so far would be the magnitude 6.2 earthquake 1922, which is somewhat closer to Bohol already, but it affected Cebu that time. But there are small events here in central Cebu in 1888 and 1887. So, there is a possibility that an earthquake can originate in Cebu. So let's move backwards by recalling what happened in Bohol last year. In Bohol, historical churches collapsed, and these were as old as 400 years ago. That would mean that prior to the 2013 earthquake, there was no major earthquake affecting Bohol in the past. And it came last year. So, if an earthquake has happened in Negros in 2012, and an earthquake happened in Bohol in 2013, is there a possibility that an earthquake in Cebu would occur? There's always the possibility. We don't know exactly when, but it is better for us to prepare. In 1922, that magnitude 6.2 earthquake affected Cebu City with an intensity 7 to 8 record. Let me read what is written in a catalog of earthquakes that we have. The area of destruction comprised the city of Cebu and the small island of Mactan. Within this area, the shocks damaged old structures, generally built of coral limestone blocks. Two very old walls, remnants of ruined buildings, and consequently standing without any connection to other structures, came down by the force of the shocks. One in the center of the city, and another in the suburb of St. Nicolas. Tile roofs, very numerous in Cebu, suffered more severely. 3 of them partly slid down, one very steep and old of the Recoletos Church and Convent, and another of a private house. The roof of the Bishop's Palace partially caved in. 1922. I think for most historical records of earthquakes in the Philippines, you would note that they would describe churches or convents or bishops' palaces or residential areas as damaged. Simply because these were the stone buildings before. The earthquakes are not targeting the priests. It just so happened that those are the stone buildings then. Another observation is that cracks in the soil were noticed chiefly in limestone banks on the seashore of Mactan. So there were fissuring and lateral spreading in the shoreline and river banks. And some kilometers north of Cebu, fissures were caused in alluvial soils and on the slopes of hills composed of limestone. Fissures in alluvial soils would mean that soft grounds are being liquefied, and fissures on the slopes of the hills composed of limestone would mean that there were landslides in the area. So strong ground shaking can cause liquefaction and landslide. If Cebu can be affected by earthquake, the next question that we need to pose would be, how then do we reduce the risk from earthquakes in Cebu and vicinity? Now, I will introduce several concepts, but this will apply not only for earthquakes, but for other hazards that might visit Cebu. The name of the organizations now in charge of disaster risk reduction and management at all levels from national to local levels would be the Disaster Risk Reduction and Management Councils. But if we hear the phrase disaster risk reduction, what do we really mean out of it? Simply, disaster risk reduction is reducing the risk. But what is risk? Disaster risk is simply the potential loss. It can mean loss of lives, injury, loss of business, property, whatever you dearly love. Disaster risk can be represented by three major parameters. And so for proper risk assessment, we have to understand these three parameters. The first is the hazard, represented by the red circle, which is the threat. It can be man-made, it can be natural. The second is the exposure, represented by the yellow circle. It can be the people, the assets, businesses, buildings in the hazard area. And vulnerability, represented by the blue circle, would mean the susceptibility to the damaging effects in terms of the physical and social aspects, and even the coping and adaptive capacities of the communities that are exposed to the hazard. Meaning, if there is a hazard, whatever communities are exposed, they are either vulnerable or they are actually resilient. So, if we represent the three major parameters, hazard, exposure, and vulnerability, as circles, they would intersect, and the intersection is the actual disaster risk. That disaster risk has a certain value, in this figure represented by the red area. Our goal is to reduce the area of this red intersection. So reduced disaster risk would mean that we implement many activities. It should be done at the family level, community level, organization or company level, and at local and national level. Can we reduce the hazard? Typically for earthquakes, no. Volcanic eruptions, no. Maybe for floods, we can. But let's say we cannot reduce the hazard. We can prevent it to go somewhere or to affect somewhere, but essentially the hazard will remain the same in terms of the circle representing the hazard. But we, both at the national and local government, and you, can actually help in understanding the hazard and assessing the hazard and the risk. And we can also monitor the possible hazard like a flood, typhoon, or even a tsunami or a volcanic eruption, and warn the communities of the possible occurrence of the hazard. But the hazard remains. So how can we reduce the risk if we cannot reduce the hazard? We can reduce the risk by reducing the exposure and the vulnerability. Reducing the exposure in terms of people is to evacuate people when there's warning. Or removing the people by relocating them to safer ground. Or if there is no people yet on dangerous grounds, then you apply the proper land use planning. And that is done at the national level. However, land use planning is influenced by how cooperative the residents and the companies are around the community. Sometimes people circumvent the land use. So to implement this properly, all of us would have to cooperate. So we can reduce the exposure by keeping people away from the dangerous areas or not investing in dangerous areas. But typically, we will run out of space if we just avoid. So the next thing we do is, even if we stay in some areas which are still a threat to certain hazards, then we can reduce their vulnerability or increase their capacity to respond to an event. So we can reduce the vulnerability. So if we can reduce the vulnerability or exposure or both, then we can significantly reduce the risk. How do we reduce the vulnerabilities? We can educate and make people aware. We can be better prepared. We can respond better and faster. And then we apply mitigation measures. Measures or countermeasures that would reduce the impact to the community and to our businesses. Can be done through engineering measures, through non-engineering measures like for coastal hazards, planting mangrove forest so that those in the coast will be better protected, and risk transfer or insurance. However, we also want everyone in schools, in local governments, of course in private organizations, to have their own business or service continuity. Meaning, preparedness so that immediately after a disaster, you can provide the appropriate service or business right away. I will expound on it in the next few slides. So that's disaster risk reduction. Identifying the measures that would reduce the risk, and when you now implement it, you call it disaster risk management. Let me now move on to an approach that I have been advocating so that we can properly diagnose and provide solutions to the problems. And this is what I call disaster imagination. Well, before I describe disaster imagination, you know that Albert Einstein is one of the most famous scientists all over the world. Okay? And he said that imagination is more important than knowledge. What does it mean? Whatever information that you have, whatever information or facts that I tell you, unless you use this, process it, and think of possible inventions or solutions to the problems, then the knowledge is just knowledge. You don't use it at all. So you need to imagine, anticipate what can happen in the future, invent things. In terms of disasters, imagine that if an earthquake happens in Cebu, you will know which areas will be affected, how many people will be affected, which buildings will be affected, and what are the solutions to the problems. You are just like a chess player, you think several moves ahead. And that's disaster imagination. But disaster imagination should be methodical. So let me now show you a step-by-step action for disaster risk management by focusing on the disaster imagination and the intervention that are actually the 4 pillars of disaster management here in the Philippines. The disaster imagination involves, first, identifying the hazards in your area and identifying the potential hazards beyond your area. For example, in the case of Super Typhoon Yolanda, we know that Palo and Tacloban were affected. But we also know that many other areas beyond these 2 cities were affected. The whole island of Leyte was affected. The whole region of Eastern Visayas was affected. Even the regions from Central to Western Philippines were affected. Meaning, you need to not only look at the hazards in your area, but also beyond, because you might be expecting help from neighboring towns and provinces, but it would not arrive because they are also affected. Because large-scale disasters affect a large-scale area. Second is, once you identify the potential hazard, then you imagine the scope of the hazard for a given magnitude of event. For example, if it's like Typhoon Glenda, affecting many parts of the Philippines, how about if it's Super Typhoon Glenda? Or if there's an earthquake, what will happen if there's a magnitude 7.5 earthquake in the Cebu fault, or a 6.5 earthquake from the same fault? We need to know the areas that will be affected. That's hazards assessment. Third is, if the hazard would occur, what will be the impact? What are the risks? What are the potential losses, the casualties, fatalities, injuries? What are the social and physical and economic impacts? So we need to progress from hazard assessment to risk assessment. Why do I emphasize this? Because typically at the local level, we stop at hazards assessment. There will be a typhoon. There will be flood. We prepare. Preparedness is important. That's why we focus also on monitoring and warning to provide early warning so that our people would also have an early action or early response. But typically, preparedness is focused on preparing people to save their own lives, to save people's lives. But in terms of businesses, are we talking about preparing our companies and businesses so that we will not be much affected during a certain event like an earthquake? After the preparedness aspect and knowing the risk, we can prioritize our mitigation countermeasures, either engineering or non-engineering measures. So those are the things that we need. Down to risk assessment so that we have a better mitigation measure. However, please also note that for small events, all of these are enough. But for big events like Super Typhoon Yolanda or a large magnitude earthquake, no matter how we prepare, no matter how we mitigate, there are remnant damages that will still happen if these events would occur. And we can predict those impact or damage scenario. Your damage scenario, if you're a company, should not only be focused on the internal effect, but also the external effect. For example, would you have water? Would you have power? Would you have communication? Will the roads leading to your office be there? Would the bridges still be operable or operational? So damage scenario, after doing preparedness and mitigation measures, can also be imagined. Why? So that our response preparedness are ready to be used immediately when these events would happen. Typically, when we respond, or before we respond, we will assess what happened in the area. We will assess what we need based on what happened in a certain area. But it will take time. We can anticipate our response before the event would happen. Otherwise, we will be very slow in responding. And that can be a common observation by our people. We can respond, we can prepare to respond, and we can even have a recovery plan prior to a disaster happening. We can modify it. So disaster imagination is simply using all the science-based steps from hazards assessment, risk assessment, and damage scenario so that we can have better preparedness, mitigation, response, and recovery interventions. Now, to bring this down to a local government and company level, let me introduce to you, I think some of you would know this, the recovery time objective concept. If you're a company like a provider of water, if there will be an earthquake, many water pipes can be destroyed. You want to supply water as soon as possible. But when is that time? When can you deliver water after a major disaster? If you say one day, we will do our best to deliver water to 40% of our customers, then that is your recovery time objective. You do everything to buy all the parts that you think will be needed if the event would happen, and train enough people so that you can really provide 40% of your service one day after. So recovery time objective is the desired window of time when business or service would have recovered a certain percentage of a normal operation. Let me explain this graph. This vertical axis would represent the rate of operation from 0 to 100%. The x-axis, the horizontal axis, is the recovery time from 0 time to a certain number of hours or days. A company or service or local government is operating at 100% prior to the disaster. But if there is a disaster, then that operation will immediately stop. Maybe for a few minutes, few hours, few days, or even more than a month or a year, depending on how they recover. So, at some point, 0% operation, you want to get back to a certain time of operation where you provide service to your local government or hospital or business to recover your business. And you will need a certain time to do that. If you don't plan for it, you don't have a recovery time objective, you will just wait and wait till you're able to recover. Okay? And that is not a very good way of responding to a disaster. Super Typhoon Yolanda affected the Tacloban Airport. And so the operation was recovered for several days, right? Maybe a day for some of the Army planes or Air Force planes, but several days for some other planes for them to use it. Now, the Department of Transport and Communication has decided that if the same event would happen in Tacloban Airport, they would be able to use the runway one day after. That's their goal. And that's the recovery time objective. So, for example, Timex, if there is a disaster in your area, and since you have a watch, what is your desired recovery time for you to operate at a certain level? Of course, you should have that. Jollibee, what is your recovery time objective for you to deliver and operate certain of your outlets? Or if you're a mayor, what is your recovery time objective for you to deliver the vital service of your local government? Or if you're RAFI, if a major earthquake happens in Cebu, when do you operate your NGO? Or universities, when do you start school again? Or if you have hospitals, when do you start your hospitals again? So recovery time objective is a deadline for you to commit. Because if we don't have it, then we will only recover when able. And that's not a very good thing. Okay. Now, if you're a local government or if you're a school or an organization that would simply focus on saving lives, there are 4 components of an early warning system to save lives. These are the hazards and risk assessment, the monitoring of the hazard, the warning and dissemination of the hazard, and more importantly, the proper response. You already know the hazards and risk assessment. These are the areas that are potentially to be affected by a strong earthquake or any hazard, who and what will be affected. Monitoring of these hazards is very important, like what's happening in typhoon, in tropical storm pa lang ba siya o typhoon na? Typhoon na siya, di ba? Typhoon Glenda. We need real-time instrumentation as possible so that we can anticipate when that event would happen. That's for typhoons and floods. For earthquake, you don't know. It will just happen. We don't have the technology yet. Now, if you monitor, you can formulate your warning, but then you disseminate the warning to the local level, down to the last resident of your community. Typically, hazard and risk assessment, monitoring, warning, and dissemination are done by national and other scientific organizations. The 4th and more important aspect of early warning is once people receive the warning, they know how to use the information and they respond properly to it. So at the local level, cities, towns, the chief executives, disaster managers should make sure that the residents are aware, are educated of the hazards that might affect their area, which areas will be affected by a particular hazard, and more importantly, what they are supposed to do. Preparedness is a very important part of proper response. For hazards that would have warning, do you have evacuation sites already selected? Do you have evacuation procedures? And do you conduct drills to test those procedures? If there is a strong earthquake, today is what? Wednesday. Friday when I'm gone. Will the occupants of the RAFI building know what to do? Do you have an evacuation area out of the building? Sorry to pose this question, but those are very simple questions. You need to have an evacuation plan. Do you plan for efficient and effective response? Of course, our colleagues from the different services would have the standard operating procedures that they follow, so that every after turnover of personnel, those that would come in would still know. But Filipinos tend to memorize what they're supposed to do. And so if there are newcomers, they are clueless on what they're supposed to do because they cannot read minds. What we're supposed to do is write standard operating procedures. Ma'am, sa university ba, meron po ba mga standard operating procedures para sundan? Ginagawa yan dapat. Do you have emergency operations plans or contingency plans? We need to have those. Otherwise, no matter how good our assessment, our monitoring and warning are, if there is no proper response, there will be no saving lives. Super Typhoon Yolanda, there was a forecast of Super Typhoon, storm surge of 5 meters high. Despite that, people died. Okay, now, how can we anticipate the potential impacts of hazards, and in particular for earthquakes? FIVOX DOSD has developed a software where we use different systems, but essentially a free software that we have been sharing with local governments and national agencies, academic partners, and even churches, Catholic Church, and even private organizations. It has 3 components. The first component is the hazard assessment module. If there is an earthquake, after a major earthquake, even without receiving reports from the field, you can actually assess the possible hazards in the area. But more importantly, you can anticipate the effects of an earthquake by just producing or preparing scenarios. For example, this map is a ground shaking intensity map if there is a magnitude 8.5 earthquake from the West Panay Fault in Panay Island. And that would mean that if such earthquake would happen, the reddish areas would be intensity 8, strong ground shaking, very destructive shaking. The yellowish areas would be intensity 7, and the greenish areas will be around 6. Blue would be around 2. So there will be strong ground shaking in the yellowish part. And the strong ground shaking would now be converted into impacts, but the impacts will be estimated in a different manner. We will also know if there will be landslides, liquefaction, if the earthquake is offshore, the possible arrival time of a tsunami, and the possible height. This module can also embed any maps available from different organizations. So we get maps from Mines and Geoscience Bureau, and even from Pagasa, so that we can overlay all the possible maps in the software together with the other hazards. For example, this is Mayon Volcano in Albay. We have trained them on how to use this software. It shows the volcanic hazards, but in Cavite, you will be able to know which cities are in strong ground shaking or not, which cities are prone to tsunami, which areas in Cavite are flood prone or to be affected by landslide or even a storm surge, all in one.